Hi everyone, myself Satya, Department of Mathematics, SNS College of Technology. In today's class, we are going to see random process. So before I enter into the topic, we should know what is meant by a random variable and what is the relationship between random variable and random process. So in random variable, just we are going to assign the number to each possible outcome. But here we are going to consider with the time. Okay. So the random variable which is depend on the time, which is called random process. Okay. Now we'll see the definition. So a random process is a collection of random variables that are functions of random variable T, and S belongs to capital S, that S is the sample space, and T belongs to capital T. Okay, this is the definition. Now we are going to see the comparison between random variable and random process. So random variable which is a function of the possible outcomes of an experiment, and random process is a function of the possible outcomes of an experiment with respect to the time. Okay, the notation is x of s comma t, and here it is mapped into the number, but here it is mapped into a waveform which is a function of t. Okay, and we will see the classification of random process. So you can see we will have x of t and t. So if x of t and t both are continuous, then we can say which is a continuous random process. X of t is discrete and t is continuous. From that we can say which is discrete random process. Okay, the next thing is x of t is continuous but t is discrete, which is continuous random sequence. So which is based on x. Okay, if x is discrete, we can have x discrete. The final answer should be discrete. Okay. The next thing is x of t is discrete, t is continuous. From that we can say discrete random process. And the next thing is x of t, t both are discrete. From that we can say discrete random sequence. Okay. So these are the classifications you have to remember. Okay. Now we will move on to the basic definitions. Okay. So the first thing is stationary process. A random process which is said to be stationary. Yes, its mean and variance which does not depend on time t, which means it should be a constant one. Okay, E of x of t is mean, which should be constant, and variance is also constant. From that we can say the given process is stationary process. Okay, and the next thing is evolutionary process. When we say a process is evolutionary, yes, if it is not stationary, then we can say it is evolutionary. Okay, so a random process that is not stationary in any sense is called as evolutionary process. Okay, the next thing is first order stationary process. Okay, a random process is called first order stationary if its first order density function does not depend on the time t, which means it should be a constant, which is yes, the first order, which means which is constant now. Okay, and the next thing is White's stationary process. When we say a random process is said to be WSS if it satisfies the following conditions. The first thing is E of x of t, it should be constant, and the second one is the autocorrelation R double x of tau equal to E of x of t into x of t plus tau. Okay, these are the two conditions. If it satisfies, we can say the given process is a WSS process. Okay, and the next thing is joint WSS, which means joint White's stationary process. The two processes x of t and y of t are said to be joint WSS process if Rxy of tau equal to E of x of t into y of t plus tau. Okay, this is the condition. If it is joint, means you can have the different variable x and y. Okay, the same autocorrelation condition. Okay, the next thing is strict sense stationary process or strongly stationary process, which is a triple S. Short form is triple S. So when we say a random process is said to be triple S if all its statistical properties do not change with time. If all its statistical properties do not change with time. So with respect to time, we don't have any deviation. Okay, that is the thing we need to understand from this. Okay, and the next thing is we'll have a note. Okay, every triple S of order 2, which is a WSS process, but not conversely. Okay, every triple S we know which is strict sense stationary process of order 2, which is a WSS process, but not the converse part. Converse means every triple S of every WSS process which is not a triple S process of order 2. That is the thing we have to understand from this. Okay, so what are the things we saw in today's class? Yes, we just recalled what is mean by a random process and what is the comparison between random variable and random process. The next thing is what are the classification under random process and what are the basic definitions we should know before enter into the problems. Okay, so these are the things we completed in today's class. The remaining things we'll see in the next class. Thank you.